Thank you everyone for attending today's webinar, The Importance of Solar Monitoring System Reliability, brought to you by Solar Power World Magazine and Moxa Americas. I'm Frank Andorka, Editorial Director of Solar Power World, and I'll be your moderator today. We would also like to thank Richard Duong from Moxa for giving us his time and insight into this topic that is becoming more and more crucial to the solar industry. Just a couple of housekeeping details before we get started. If you wish to tweet about this webinar anytime during or after, you can use the hashtag SolarWebinar. We love social media, and we hope you do too. You can follow us at @SolarPowerWorld or me at SolarFrankA. We will have a Q&A session with the presenter after the presentation, so go ahead and submit your questions at any time. Questions can be asked using the GoToWebinar on your screen, and I will ask as many as we have time for after Mr. Duong is finished. As I mentioned earlier, our presenter is Richard Duong, Business Development Manager for Renewable and Smart Energy for Moxa Americas in Brea, California. Mr. Duong graduated from Carnegie Mellon University with a BS in Electrical and Computer Engineering, and currently works to create new business and grow existing accounts to support annual sales growth of more than 20%. He was also kind enough to contribute to our May 2013 cover story, The Pressure to Perform, which dealt with this absolutely crucial issue of monitoring. It's my pleasure and privilege to introduce to you Richard Duong. Richard, thanks for joining us today.
Thank you, Frank. Keep me 1 second to take the keyboard and mouse here. So today's webinar, we're just quickly going over the importance of solar monitoring system reliability. And the term reliability has many perceptions, many connotations, many different meanings to the people involved, both on the manufacturing, the installation side, as well as the end user. Here at Moxa, we've invested in our own solar array, and I was on the committee here during the construction, the selection of our vendors as well. And it was, we had our own challenges as we built this up. Just learning through how to deal with the finances, the logistics, and hopefully I can share some of that today throughout this presentation and relating to our own experience with owning a solar array. So how we consume energy has changed over the years. We see today more and more electric vehicles becoming extremely popular, even electric motorcycles. Our devices are taking much more electricity than before. Our MP3 players, our cell phones, as well as our tablet computers, our digital cameras, all things that used to be consume a lot less electricity, as well as being like cameras, for example, were chemical-based. So the way we consume energy has changed. We're definitely consuming more today than we were yesterday. And in addition, the price of this energy has become more and more expensive. So we have to think about ways that we can generate this energy. Up to today, we've been using fossil fuels, and we've become extremely dependent. And as we know that there's a finite limitation of these fossil fuels, we're starting to look at more renewable, sustainable energy. You can see on the far right over here, that is actually Moxa's solar array. That is the Moxa U.S. corporate headquarters. And that is a 1,133 solar, 175 watt panels that are on our roof and carport arrays. And it was quite a process getting that whole array built up. And we've learned a lot just in the requirements of getting one built, getting through management to justify the return on investment, getting through city municipals under construction, and we live here in California, so just getting past the earthquake laws as well were exceptionally challenging. So beyond this generation of energy, you see that, in that last example, that the solar array was actually on location where we use it. So how we transfer this energy is also changing. And how we move forward with transferring this energy to where it needs to be used is also changing. The efficiency of traditional top-down electricity, where power is generated at a off-site location, usually your utility company, pushed down the line and getting to your homes and your companies and your factories and such, is very inefficient. There's a lot of loss. There's a lot of maintenance that needs to be done. However, because the generation is done in bulk, there is an advantage at the moment to the cost. But over time, we found ways to change this infrastructure, and that's part of what this Smart Grid initiative is to spread the power out from a single top-down centralized generation model into this new transactive energy, distributed energy model. And you see here on the right with this grid modernization, we're going to have large, UPS systems in our car, and that's what an electric vehicle is today. Large battery packs. Maybe one day they'll be used to transport energy from one location to another. At the same time, as we distribute these solar arrays out into people's rooftops, commercial building rooftops, and such, the power generation is done exactly where it's being used. So the ability to create single buildings, single users, single communities that are net zero in power also comes up. But one of the biggest challenges here as well, as you can see on that left side, is the different components. So solar can power for maybe about one-third of the day. What are we going to do in those nighttime hours? Do we create battery backups? Do we have to look at other ways that we can acquire power? Maybe one day they'll be running off of our, car's battery system overnight. It's still to be determined. But definitely, there's been an initiative to this distributed power generation, and part of this distributed power generation is really the growth of the solar renewable market. And its ability to bring smaller size in the scale of 2 megawatt to 5 megawatt size solar power plants into a smaller location, into a community, but have many of them to power an area. For example, the Moxa America's headquarters here in Brea, California, we on a daily average consume roughly equal to the amount that we generate, and that is pretty close to 1,800 kilowatt hours per day. And that is even with running the air conditioners, having close to, I think, 20,000 square feet of floor space as well. In addition to the way that we transfer this energy, we were going to need better ways of keeping track of energy. Yesterday's power meter was these old analog meters that someone had to come out and write down the numbers and see. And today we have a lot of these smart meters, both in that we see down here in Southern California as well, and as in other areas. Those smart meters are great, but there really is a limited amount of infrastructure that's built around to reading them. Most of the time they're picked up by a truck or like a local relay. Moxa has gotten into developing some of these solutions with Taiwan Power, and we've learned a lot in the developments there. We were co-working about with taking these smart meters and relaying them to data concentrators and coming back to the power utility headquarters so they can monitor, turn on, turn off, and see the power that's being used at any point in time. Realistically, though, these new smart meters have a limited amount of data in them. They have your total amount of energy used in 15 minutes during the day, during the month as well as an accumulator, as well as they're looking for peak powers in 15-minute intervals, as well as power consumptions in those intervals. They're also paying attention if you're running your power meter backwards, as in generating against the grid, like inserting power back into the grid. So these things have a lot of ability, but they're not quite being utilized, and their sample rates are fairly low. Moving into the future, we see a lot of these monitoring systems today in the solar market being capable of doing even down to sampling of less than a minute, which you can get, specific data from individual breaker loads, maybe your air conditioning, figuring out a little bit more about your refrigerator. And you can see that these products are starting to pop out in the market today. Your heating and ventilation is one of the largest consumers of electricity in your building. And you see products like this Nest thermostat now being integrated with Zigbee, which is the same communication technology that your smart meters are being built with. So, as this technology transition, we really become more aware of the power consumption that we're using. In a day, you usually pay attention to how much battery you have in your smartphone. You charge it. Electric vehicles, you're constantly worried about the range. Laptops, if you're flying, traveling, you're paying attention to how many hours your laptop can run at any particular state. So the public's awareness of the usage of power has definitely changed over the years. And as our solar buildings come up, we're also at a technology point where we can actually reach net zero building power and have it financially feasible. However, there are a lot of strings attached to producing net zero power efficiently. You have a lot of things, the amount of sunlight that's available in your area, how much snow you may have there, state and local incentives to building this, state requirements, can all impact the cost of this energy that you're producing at a building level. But there's still a strong push towards the adoption of growing this renewable energy. So there's still a lot of questions that need to be answered, infrastructure and public policy that needs to be figured out. But there's definitely an initiative that over the next 10 years or so, we're going to have more and more solar energy spread out through our city. The question here lies where and how and who's going to own this solar power. I can tell you here at Moxa, we actually paid out. We didn't. There's a couple of different ways you can get this power. One way is leasing up a system from a provider and then buying power from at a lower rate than your utility. We went out and said, let's make this a research project as well. So we bought the entire solar system, but at the same time, it was fairly financially feasible. As you can see here, based on our building's power consumption, the cost that we got the system, the way that we selected what was going into our system, we can cover up to 105% of our power usage on a monthly basis, as well as have an ROI of roughly 5 years, and that's fairly good, in this time. There was a lot of calculations that came out to this, and there's a lot of estimates. However, in reality, this ROI is going to get stretched out. Every time you need to service something, you have to turn off the system. Every time something breaks, it takes a certain amount of time to respond to it. A day, 2 days, 5 days, if there's parts on order and such. This all becomes something that impacts the way the finances of owning the system is calculated. So you really need the right information from the data that you collect. So the first problem is getting that data to be consistent, reliable, accurate, and then delivering that data using software algorithms, servers, like regional analytics, weather reports, weather sensors, current sensors, taking all that data, making it into a piece of information that you can see. On the left over here, you can see one of our partners who had built up basically a data accumulator for our site. These are all the different types of sensors that we have on our site, and it's raw data values. It's great data, but taking that to another level, you can see that there's on the right side is a dashboard that we have for our site, and it's actually a public dashboard. Anyone can take a look at it. Right around 1,600 kilowatt hours is kind of where our average annual average for the daily generation. It's about 1,600 kilowatt hours per day. On an annual basis, we're shooting for somewhere around 500 or so 500,000 kilowatt hours per year, which is pretty close to zeroing out our energy footprint. As you can see on this graph on the right, the green is our generation, the brown orangish color is our actual building consumption. And there's some days that it's over, there's some days that it's under. On the weekends, you can see the little dips on the orange where we actually surplus that the energy. The current way the accounting for that goes is we get a credit back on the kilowatt hours, and then it gets used towards our consumption during the nighttime that we use it, use power off the grid. So part of dealing with a lot of this data, these data sets, these information sets, we've noticed that missing data really makes it difficult to figure out when the exact ROI is going to be. We've recently had a couple of incidents on our solar array that we've had to take the whole system down for a couple of days to do some service. 2 days of 2 days of taking the system down impacts the amount of time it takes to repay back the cost of building the system. Just for your reference, the system that we got installed is roughly, I think it's about roughly $935,000 pre-incentives. So after the incentives, it takes you to between federal, state, and tax incentives. It takes you roughly about a third of that value. So if you're not at full operation, you're losing money on a daily basis. If there's broken strings in your system, if your panels are dirty. On the left here is a real picture of, we had an incident where the neutral, there was a short on the neutral line and caused a little little meltdown in one of the insulation over here. And these things, you know, not only impact you on the cost of replacing the equipment, replacing any damaged equipment, it's also impacting you on the ability to achieve that ROI. Because there's definitely a finite amount of time that your equipment will survive. And with that equipment also comes the different efficiency of the components that get put together. One more thing I'd like to add on this screen is this is an example of a string combiner. How do you know if a fuse is blown? So with these different efficiencies of a system, you see challenges like cabling. One of the biggest challenges that we had in construction of the building was the length of cable that we had to run. We used a central inverter system in our building, so one large inverter for the entire building versus the more distributed microinverter approach. And we felt that this was the right way at the time because it gave us better efficiency from the inverter into the grid. And that's where we wanted to optimize. But also gave us a lot of open-ended ability to construct data monitoring on the DC side. But with your cabling, your inverter, and the selection of PVs, the angle of the array, the average sun at your location, these all impact what efficiency your system puts out. And it's going to be different for every system that's installed. They're always going to be a little different. You're going to be able to calculate a little bit of this if you've got a systems integrator that has a lot of ability to do a lot of math and a lot of statistics on what they've done before. But for the most part, taking spec sheets from like a panel manufacturer, taking spec sheets from your inverter manufacturer, you really can't tell what the real actual output's going to be. And, you know, so we come back to this big question, like, what is reliability? And reliability plays a different problem, question, solution for the different people that are involved. As a facility owner, as a solar array owner, reliability to me means that the system stays operational. To a data collection software company, it's making sure that the end devices, the server devices, stay online and there's continuously data flow. As a hardware manufacturer like Moxa, like our products are designed for environmental reliability. So we go through standard tests like the IEC 61850-3 standard, which sub-references environmental standards such as ESD, radiated, RFI, electrical burst, surge, voltage ripples and such, temperature ranges based on the location of the equipment. So reliability has a lot of different interpretations. And there's a lot of different solutions that you can use to create reliability of your entire facility, solar system, site, or solar design. And one of the first places to go is reliability via interoperation. So I've been involved with the SunSpec Alliance for some time now while I've been here at Moxa. And one of their biggest challenges just to get all this equipment that you put in a solar facility on the same page working consistently. Because if you have two products that interpreted a certain design standard differently, what you end up with is a failure in the communication, which causes the failure of the reliability of the two devices communicating together. And in that incident, it's it's always challenging to figure out who broke the particular thing. And the SunSpec Alliance puts on these plug fests and design calls and committees and such. And we work on these things so that we can have better interoperability inside of the industry. At the same time, another way you can look at reliability is via the ability to keep your product warrantied. So solar panels have varying warranties from 10 years, 15 years, 25 years, but they all guarantee that there's going to be some profile that the solar power panel will wear out at. So a solar panel installed outside will produce the most power in the beginning of its lifetime. Now, the longer that it's outside and in use, it starts to wear out. So you want to definitely take a look at your system's reliability in the beginning half of its life, because it's going to impact your ability to achieve your ROI the most. At the same time, inverters are usually warranted for a fraction of that, and their real life is pretty close to their warranties. And at some point, you may get a better inverter, a bigger inverter, a more efficient inverter, but it's all something to look at as part of your reliability plan. If you're going to have the system down for 3 weeks while you're getting your new inverter installed, or maybe you're just taking the inverter and replacing individual parts that may take a certain amount of time to order while it's offline, all things that are going to impact your system's reliability as well as your ability to achieve your plan on your return on investment. What we deal with here is typically the solar data loggers. So our risk embedded computers typically come with a 5-year warranty with MTBFs of as much as 19 years or so. So that's how we've got into this business, is we made products that were highly targeted at providing a certain quality of service over time. At the same time, we sell these products to our solar software integrators, and they build up their software, and that's ideally the best place for this type of data to go, is into a server-based system off-site, so you're not fully reliant on a local device to buffer data, because you never know what will happen on a local site. So in creating products with high reliability, the easiest metric is to figure out what the real mean time between failure number is. And there's ways of doing initial design testing through heated and cooled chambers. There's initial burn-in just to make sure that products are up to par when they're manufactured. And there's also specialty, wide temperature testing during production side. So all of these are items that hardware manufacturers like Moxa and the other brands can do to help mitigate the amount of failures that happen with the product once they're in the field. As you can see here, this is actually a special heating chamber, but this particular example is one that is a fanless heating and cooling enclosure. So it's all radiated heat and cooling, which is very similar to these enclosures that you use outdoors, where most of this equipment will likely be installed. And that whole process of design testing, running the temperature up and down, it's all outlined in many of these IEC numbers, and most of it's gibberish to common folk like you and I. We leave it to the R&D engineers to figure that out. But just as a visual example of what happens during production screening, Here is an example of a ramp up and down temperature range for a product that we actually ship now, just for you to see. You'll take it up and down between the temperature, humidity, and then once it gets through while it's functioning, if there's no failures on the software, if there's no errors, if the system doesn't crash during the process, it usually gets the rubber stamp and sent out as a proper product. The problem is that not everybody does that. Specifically, not everyone even screens it besides standard production testing. And that's one of the things that you need to look at as a hardware, as a software or a solutions seller, from your hardware manufacturer. So the easiest thing for us here, getting back to reliability, is reliability check via our utility bill. This is an estimate of what our power usage would be on a monthly basis here at our building, and where we think, our integrator thought our solar production would be. So looking at these numbers, the amount of energy that we need to purchase every month has been, has been one of our metrics of checking our integrator to see if the system has been functioning the way that we expected it to function. And we've definitely been able to reduce our monthly energy bill quite substantially. We had some pretty hefty ones right in the beginning. Definitely when we bought this building just a couple of years ago, there was a lot of sticker shock and once we got the energy bill. But once all the solar system got turned on, got settled in, it definitely brought that monthly bill down substantially. And once that bill has come down, the amount of questions regarding the ROI definitely came down to our committee. So again, I say that different system owners have different needs. So in the big picture, it's about figuring out who's going to be the owner. To this point, as a company, Moxa has been interacting a lot with the PV panel manufacturers. They're heavily involved in, especially the ones that are dealing with integrated products, that relate to their brand. Because most PV, there's very little differences between one brand and another. You may get better service. You may get a little bit more power density. You may be able to get a little bit better peak power. There's a lot of numbers that makes it very difficult to differentiate. And it's the same with inverters. The ability to determine one inverter to another with their efficiencies, their performance levels, their reliability. So that's kind of where we started talking to the market. As this has changed over time, we see that the engineering firms were interested. The subcontractors that were doing the installs were interested, and there's definitely products in the market that fit into that systems integrator profile. Very off-the-shelf hardware with some level of software. Just canned product that works well for those people. But as we're seeing that market change again, we're really realizing that the performance of the system, the performance of any of the components, the performance is important to the people investing the money to make it happen. If your pitch is to produce energy cheaper than the traditional sources are, you're going to have to you're going to have to prove that it's actually true, and prove that the system can stay online long enough. Prove that that the components aren't going to fail and impact the ROI of the system. So the investors are now a little bit more vested into paying attention to this. but they want the transparency. They don't want to deal with a lot of that data. They want to be able to get the alarms, the analytics, the high-level information behind it. If a bank is loaning you $1 million to build out your solar array, if your solar array is not going to meet its ROI targets, that solar array might be a failure, and the bank doesn't want to repossess all the assets if you're not going to pay back the loan. The municipal, they're tracking these powers. Maybe they need to get the performance number of their solar systems that are impacting their power quality on the lines. You'll see this come up where the utility companies want to be able to cope with your individual inverter. At the moment, it's very difficult to shut off your inverter, but you are generating electricity into the grid against their power. And it's basically the end user's job in the inverter to figure out how to track against the AC power and insert that power back. This opens a whole can of worms with power quality. So your solar site, let's say it went rogue, may impact the ability of the power utility to provide power in that area. Maybe you'll blow out a line. Maybe you'll blow out a transformer when something comes out. There's a hefty process in doing this where the utility has to sign off on your site before they allow you to get plugged in. But at the same time, they have very little ability to control the way that you insert your power back to the grid. And it creates a whole bunch of challenges because you have different inverter brands, different inverter qualities, different inverter sizes. We've seen the largest growth to this point in solar systems as far as our customers in the light industrial to large commercial. And that's usually because the return on investment seems to work the best right around that location. Those are the people who are actually impacted by the amount of electricity they use on a monthly basis. For example, when you're an individual and you're paying about $100 a month on electricity, it doesn't bother you as much as a company that may be spending $5,000, $10,000, $15,000 on electricity per month. When they're spending that much money, they have more of an ability to invest to reduce this power consumption and bring it down and make it much more manageable. Part of installing these solar monitoring systems is also installing monitoring equipment for the power consumption at your site. And it makes a huge difference on your total footprint against the grid. So quickly going over some of the designs that I was talking about. This is an example of a monolithic solar system where you have the arrays going into string combiners, going into a large central inverter, and then spitting out to a revenue meter and then connecting back to the grid. This is for all intents and purposes, this is the traditional sense of how you would design a standard system. Over time, this has changed a little bit, and running all that DC cabling uses a lot of high gauge wire, creates a lot of heat on the conductors. The string combining is rather challenging because your strings may have different voltages once the panels line up. So that approach has changed a little bit into more of a distributed type of architecture where you're using smaller inverters and more of them. At the same time, when you're getting down into like a residential size, your small inverter is your only inverter. And part of that is looking at this monitoring, making this monitoring equipment that was once designed for this giant monolithic system into a price point that is more reasonable into these more distributed systems. So this is an example of what we got involved in, not necessarily solar, but it's very similar. It's the power monitoring. So being able to spread out your system's power monitoring and bring it back to a control center that's actually paying attention to the loads, the generation, et cetera, on a citywide scale. In this example, you can see that we got involved in Taiwan Power, where they're connecting a bunch of these meters and aggregating it back to what we call a data concentration unit, and then sending it back into the grid in one of various ways. In a residential solar system, you're also dealing with a particular challenge, is that you've got a piece of equipment, for the most part, that runs through your home network. And there's always been this problem of your solar system shouldn't be connected to your home network. But if you don't connect it to your home network, how is it going to get data back to the remote site? Your cloud-based, like a solar monitoring system. If you don't do that, cellular in America really hasn't gotten to the price that is feasible yet. And there have been big strides towards making it feasible. Things like the Kindle and such, where they're using a small amount of bandwidth and making it feasible. But it really hasn't made its way to the solar market yet. So usually you're tied to getting, if you go the solar route, you're tied to getting a SIM card with a contract, and that's kind of all tied together with your monitoring contract and brings up the entire price. So it's all something that you pay attention to once you install your system. And what are the maintenance costs? What are the service costs? And this is something that most people neglect when they're trying to figure out their ROI. So in a commercial system, you have a lot more flexibility, but you tend to have a lot of similar equipment that's needed in a residential system that gets left out. The commercial system will include it because there's a little bit more of a cost value buffer in between it. You may have a generation and a consumption meter, and those are pretty hefty price per meter. Weather stations, other monitoring equipment that's integrated into your inverter, and then pushing all that data off to the cloud. Here in a commercial building like ourselves, it's always a challenge getting an outside piece of equipment that's connected to your solar system through your IT system. So that's, again, a problem of trying to get through your network. It would just be so easy to plug it in if it was a small to medium site and you didn't have an IT administrator. But as a commercial building, it's something that we have to deal with. Here's an example of getting into your large commercial, light industrial, even up to borderline. I would say, actually, I'll stay with there, with large commercial and light industrial. This is a cabinet that you'll see that will be outside in the array. Not really much of a shelter. It just blocks some sunlight off the top. But equipment's crammed into a small enclosure. You've got heat generating sources like the power supplies and such. And it becomes more important that these data logger, gateway monitoring components have temperature fluctuation ratings. It could be snowing outside. It could be in the middle of the desert in Nevada. How do you keep these components functioning so that your data is consistent over the period that you have your system. And just to add, this is an example of a way that some of our customers have converted to buying our products in the past. We're using their own spin, like home spin, single board computers and integrating in. It's crude, but it was effective. But the problem is getting the support. So in this example, our customer had a problem with their previous vendor from just managing the operating systems, the kernel builds, the integration of the product. They decided that it would be cheaper to integrate the whole product themselves, and it was, I would say, fairly cheap, like substantially cheaper on a single unit cost. But what was usually neglected in the incident of the decision process was that when something happens, how much resources do you have internally to deal with it? Do you have the team that is capable of debugging the code, debugging the boards, debugging the subcomponents versus having a one-stop solution for a hardware solution? And that's an example of value that comes to the table when you're dealing with these types of projects. Whether you're home building it or having a manufacturer build it for you. So kind of as a recap, what is solar system reliability? It's always going to be different depending on who's involved. But the most important aspect is achieving your design and financial goals. If your goal is to pay the system off in 5 years, 7 years, 15 years, if your design left a buffer for downtime, repairs, engineering factors, and maintaining whatever your design goal was, maintaining that quality of service over the system lifetime, planning your inverter swap outs, planning your monitoring system swap outs. If you're, will that monitoring system company even be around 5 years from now? What's going to happen to your data? And the accounting behind it. Auditing your systems integrator, making sure that your real-world performance is the same thing that was on the contract. Making sure that things that you negotiate on your contract beforehand is line items in the final product that gets signed. And the last, more importantly, is that company going to be around to deliver on their agreed contract and warranties? Do they have the reputation going backwards, and do you think that they're going to be around moving forward to deal with any problems that you have? What kind of customer service, what kind of support team are they going to have to deal with you? There's a lot of flux in determining that these days, because there's a lot of passing through. But I feel that heavily the systems integrator should be your point of contact dealing with the other components in your system. It's one of the only ways to make this feasible moving forward. And then most importantly, is the fire and safety hazards. We've had a couple of incidents here that came up. Definitely something you want to pay attention for. These monitoring systems, when you see loss of production, if you see something doesn't look right on the numbers, maybe it's time to go outside and take a look for yourself. Maybe call your electrician to take a look. Call your installer to take a look if there's something wrong. Because there's always, things will always come about. Maybe any number of reasons that will cause a system to have issues. Just recently we had someone drive a truck into our array, and we have to get it repaired coming up shortly. So that's all I have for you today. Thanks for your time. I'm open to to questions if anybody has them. And I think, Frank, you still there?
Yeah, I'm here. Thank you, Richard. I really appreciate your time, and we all really appreciate your time. We do have a few questions, if we can run through them here. The first one, Tom had a couple of questions. He wanted to know which of the inverters that Moxa had on its system went down for 2 days, and how many kilowatts did that hit, and then why was there a single point of failure for the system?
We've had various challenges owning our system. We've had a inverter. We're running a 300 kilowatt inverter today. It's like it's a Power One inverter. It got covered under warranty, but we had one of the drawers fry out. We had to get it replaced, and that took some time to get sorted out. Recently, we had a combiner box that went out. That's about 50 kilowatts worth of power that went out, and nowhere to route the panel generation during that process because everything has to get shut down from the combiner box. So there's a number of reasons that your system can go out. 50 kilowatts of DC side power ends up being probably, it impacted our array probably about 300, let me see, 1 second. Let me do the math in my head. Probably about I would say 400 kilowatt hours in our system on a daily basis. So it impacts, and every time in a central inverter system like the one that we have, when there's problems, you really have to take down sections of your array at once versus taking down everything that's to a smaller sub-inverter.
Thanks, Richard. Jason asks, what about the IEEE 1547.3? And for those of you who don't know what that is, that's the electrical regulation of monitoring and how the systems talk to each other.
I'm not particularly familiar with that particular spec. I can definitely look it over and follow up on that question.
All right, Lee asks, isn't there a major issue that the solar monitoring and the interconnecting monitoring, either net or gross, are not in the same database? Solar for the owner-operator and interconnection for the utility.
Yeah, there's definitely some challenges there. They're kind of two separate spaces today. Your power meter that's owned by your utility has one set of readings, and they're not very granular. I mean, they are very granular on as an accumulator, like calculating the total number of kilowatt hours that you pull down or push up. They're not very granular on determining that amount over a short amount of time. So usually it's a 15-minute cycle. Your third, like in California here, we have a third-party monitoring service that pulls our data from our site and delivers it to for us would be Southern California Edison, and that's a completely separate database. We do have a couple of power meters that are in the same location, that would have the same data and information that the utility meter would have, but it's on our side of the bus. But they're definitely two separate items. It's still going to take a little time for cities and integrated. The individual, like solar monitoring, has to come a little bit way up into providing a higher quality, consistent product. And the power companies have to be willing to kind of come down a little bit and allow integration of some of this data. And at the very moment, I think there's very little integration.
Richard, Michael asks, what are the key criteria for selecting a monitoring system vendor?
With monitoring systems, it was, I'll tell you the truth, when we were building our systems, the final choice of the monitoring system kind of became an afterthought in the selection process. We spent so much time determining what kind of panels we were going to get, what kind of inverters we were going to get, our vendor, like how they were going to cable them, etc. When it comes to solar monitoring systems, you want a way that you can actually keep track of the energy that you're producing, that works for you, that is in a way that you can understand it, and that you can own the ability to audit your integrator or your inverter manufacturer or your panel manufacturer. Because the largest challenge today is that it's hard to, it's kind of a finger-pointing game of who's accountable and who has, which component is not performing properly on your site. And it's really up to you to figure out, unless you're leasing the system, it's really up to you to figure out what kind of metrics that you need to pay attention to, and what kind of alarms, what kind of data connectivity to keep an eye on the other guys.
Can you tell our attendees, Richard, what the typical kinds of alerts are that your customers are getting?
Could you elaborate more on that question?
Yeah, I'm sorry. When they set up alert systems, because you're getting so much information, they obviously can't process it all themselves. So they get alerts sent to them when something goes wrong with the system. Can you give us a few examples of what typically people are getting alerts on, what kinds of things they're getting alerts on?
For our building, running managing the solar system isn't our primary job. So we have to limit the amount of information that gets reported back from, that gets alarmed from our solar system. What we do have from our systems integrator, a solar installer, is we know that we need to produce X amount of power on average on a daily basis. So what we did was we took that number and divided on into which is about 1,600 kilowatt hours per day, and I generated an alarm to monitor at that point. So when we're below that point, I get the daily report that this number is down. And once I get that report, I start paying, and the numbers have been down for a day, 2 days. It may be correlated with the weather. It may be correlated with the system being down. But if you have large number of consecutive days where you're not meeting the average power, like roughly the average power, or at least the minimum power that you're expected to put out, that's usually the point of concern that you need to look into the details of your system.
Very good. Well, that's all the time we have for today, but if you have any further questions for Richard, you can send your questions to me at fndorka@solarpowerworldonline, and I will pass them along to him. Thanks, everyone, for attending this webinar, brought to you by Solar Power World and Moxa Americas. For those of you who are asking if you can get a copy of the presentation, this presentation will be emailed to everyone later today and will also be available at our website, which is www.solarpowerworldonline.com. Thanks again, everyone. Thanks again to Richard and for Moxa America's participation in this webinar. Until next time.
Thank you.